れで大丈夫かな。よし、OK。では、始めますと。うん。タイプスクリプトのウェカのタイプスクリプトラウンドファンダメント。This is the project-based cost-effective way to approximate its housing. 大体2時間で終わる。Before diving into the user is going to focus on learning object. タイプと何かということと、Why companies 会社は使っているか。Learn all the basic types and use them. Strings, numbers 基本的なデータ型を覚える。Learn advanced type using them easy enums として拡張型。Write codes and understand all the principles in TypeScript. やるワールドでもいいかな。ステップ貼ってた。が始める。about でライムを使う。meet the instruct。数字範囲、インド人っぽいなぁ。いうのをやる。次の項目の了解で、第にこれについてビデオをやると。これは、こっちでも、できるようにしたから、えーと、タイプスクリプトヒーロー、ダスレススタイルズ、ESX、なんでしょう。アンギュラーとかタイプスクリプトプラグイン、ES 使わなくていい。で、拡張機能を一回一覧して、VS コード入れるかどうか。かわいい。どうもありがとうございます。拡張機能は、インテグラムスリンター、マークダウンリンク。マークダウンリンクは、とりあえず無効でいいかな。あとはまあ、そのまま入れといて、ラベル JavaScript で有効にする。コードビルダー、有効にすると。HTML ラベルと Java でばっかから、ライブサスコンパイラーはインストール。ライブサーバーはそのまま。そして、こっち。 ビデオとかをやるラインコムを有効化すると。前として、ビデオだけでいいんだよね。Google APS で、ビデオをオンで、読み込みと。
Hello and welcome to the course. My name's Rudy and I'm a full stack developer and DevOps engineer. And today we're going to be learning about TypeScript. By the end of this course, you're going to know what TypeScript is, what the benefits of TypeScript are, and you'll be ready to start implementing TypeScript in your JavaScript code at work, or even to start using it on your own personal projects. Now, in order to follow on effectively, it is recommended that you do already have a working knowledge, or at least an understanding of JavaScript on a basic to intermediate level. For example, you should already know what variables are, different data types, so primitives, arrays, objects, strings, booleans, etc., classes, functions, and ideally you should have worked on some kind of JavaScript or Node.js projects in the past in some capacity. Just a quick introduction to the RIME interface here. So on the right hand side of the screen, you'll be able to see my controls here. You can expand or collapse the view down to actually make it easier for you to see your own workspace on the left hand side, which is a Linux or Ubuntu cloud desktop, which gives you all of the files that I have access to as a copy of on your side, and it's fully interactive and you'll be able to follow along exactly what I'm actually doing in the code on the right. You have full controls over the video on the right hand side, so you can pause or play at any time, rewind, fast forward, skip or go back to previous lectures. And feel free to pause the video, and if you need to digest or practice a little bit more, or rewind if you need to go back and get a bit more clarity. So, what exactly is TypeScript? Well, the best way we're actually going to learn this is actually to practice it, which we're going to get onto shortly. But to summarize, we could say TypeScript is a typed superset of JavaScript that pretty much compiles in the end down to plain JavaScript, as we know, because the browser only understands JavaScript. But we take something like the program TSC, which helps us to compile the TypeScript down to JavaScript. It's an object-oriented style language with classes, interfaces. It almost mimics a statically typed programming language, something like C or Java. TypeScript is fully compatible with ES6 JavaScript, so we can use our arrow functions and all of the ES6 features. And the main benefit that TypeScript gives to us is to allow us to implement this sort of statically typed checking. As we know, JavaScript itself is a dynamically typed language, so in general, we don't need to specify the type of variable, the type of function. For example, we don't need to specify that a variable should be of type string or should be of type number or should be of type array, for example, like we have to in a language like Java. But what TypeScript does is it allows us to implement this sort of static type checking, and the benefit of that is it allows us to highlight and determine what could be errors and what's not errors at the time of compilation, compiling the code, as opposed to runtime. So we don't actually have to run the scripts themselves. So it allows us to detect more errors and saves us time in the long run. It also allows us for a more readable and tightly controlled code. So we can get a better control of the actual code itself, ideally, in the end, preventing more bugs and preventing issues from potentially arising in the future, as we know when code is worked on in a collaborative nature. But as we said, the best way is to actually practice. So in the next task, we're going to go ahead and jump straight on into practice some TypeScript and start understanding the different types and the syntax that we actually follow with TypeScript. So I'll see you there.
まずはタイプスクリプト。大体の概
括。Welcome back. So in this task, we're going to get an idea now of how we would start to write our type checking in JavaScript with the help of TypeScript. And to do that, the first thing we're going to need to do is to head over here now into our TypeScript folder and create a new file which has the extension .ts on the end. So for this, we'll just create a types.ts.
とりあえず、KTS を読んでみよう。で、そうすると、こっちのコードには、ビギドンロール、今のが入ってる。ISG なのか。まあいいでしょう。そして、コントロールセーブで、まあ、
That create a TypeScript file.
です。ここに、出す。タイプ点 ts。
For us. And just to make sure that we know that's working, we're going to log out, of course, a hello world. And then we'll go ahead, head over to our terminal here, make sure we're in the right folder. And what we want to do is we want to run tsc types.ts and hit enter.
TS やつだっけ？ないなればいいけど。実行。あれ？クローム？違うの。ターミナルで売りたいんだよ。TSC。入ってないな。じゃあ、これはこっちで。これだから CD タイプスクリプトファンダメンタル。ここで PNP アインストール。一応ディノも入れてみよう。TSC タイプティトン TS。 TS されたのか、NPX。Use YAN to avoid to PNPM の。ここちゃんと作ってよかったな。タイムスキルの一回抜けて、ここはYAN。YAN イニット。RM の PN。やっケージ。つかない。Git。Git。ストア、ピーロード。パッケージ JS と。じゃあいいかな。バット TSC。これで TSC はピリオ。一回。えーっと、これ作るのがめんどくさい。点押すで一回ここを戻す。ここでできるんだけど、部分ツだとあれなんだよな。タイプスクリプトのパッケージロックをもう一回ダウンロードして、アプリケーションにダウンロード。そしてこれを、ダウンロード。スラッシュ CP に VS コード。いやー、DNP も。ギターコンフィグはまあ、いいっていうの。いやー、ゲームタイプってやつなんで。で、その、ビジュアルスタジオコードは一回、削除。 これで、こうなったから、いやーん、あと、タイプスクリプト。デバでも今話していいでしょう。セットアップじゃあ PNPM? パッドの TSC。これは簡単に言ったな。ノードモジュールス、セット、PNPM、スラッシュ、LS、ノードモジュールス、bin、TSC、PMD、タイプって、yes。NPX、use yarn って言えばいい。もうやっぱし、NPM、-S。これ時間かかるなぁ。いいやん。とダメだ。ダメだ。ダメだ。あ、せっかくゲストノーツ。つまり、rm-r のモジュールスと一回抜けて、move json.org とし、yarn.ts アットのいた。あとは、っていうのも言ったかな。いや、行かない。まあ、とはいえ、メインは TSC。ー、とすると、うーん、いや、いや、で、 いやーん、ラン、ESC はできるか。これでやれってこと？これで NPXTSC？ 全部一緒だな。では、2CPN のタイプスキドハンドメイド。これまでこんなにいいざ。やんで入ってるんだよね。ラン TSC マイナスヘルプやってみよう。ランの TSC。全然。うーん。タイプ 10TS。いかない。とりあえず、じゃあ仕方ない。上でこっちのインストラクターはこうなってるから、遅いんだけど、こっちでちょっと試してみよう。なってて、この辺は違うな。全部のログ。これでいいはず。フォント証言。TSC? タイプとの TS? え、そうすると、タイプ 10JS ができる。さて、じゃあ、もう一回これをこっちに戻ってみよう。待って。 これはこっちで、タイプスか。イニットを使えばいいのかな？イヤン、ラン、tsc マイナスイニット。なんか、tsc ミニのイニット。ありかない。えーと、マイナスイニット。これで、じゃあどうすればいいんだ？これがダメならば、ドキュメンツじゃなくて、ワークスペース、エデュケーション、ノートのコーセラの CPU の戻して、後で、もう一回入れ直す。うーん。ESC さん、ESC です。これ出なきゃいけない。もう一回、パッケージをやって、うーん。ストアと ESC。タイプスクリプト。TSC。もっと取りようかね。まあいいや、ノードモジュール、ビン、スラップ、TSC、CMD、イニット。うーん。だ。 こっちは後で、ここはノード、タイプ、S で、こう行くのは分かってる。だからここはで100% にして、セッティングはアクセスブルボードにして、動かすだけにしたいんだけどね。可能性はあるな。全部消しましょう。消す。このノードコンフィグやっていい違いしないから、これも消すと。さて。それで、いやーの、汚いな。ワークスピード。パターンから見て、これをオーブンで、見に、これどうだ。マイナス i。で、パッケージでその登録どうだろう。実ね、ヤンイニット。パッケージマネージャーが入るだけか。じゃあ CP のパッケージ JSON、オーブンのパッケージ JSON でいいじゃん。で、ヤン。で、しかも PNPM でタイプスクリプトだけ入れてる。これで TSC が動くか。じゃあ、ノードモジュール、インス TSC。これで動かない場合は、ジピターラボ。これも次がジピターネットワーク、ユーズでの。ブリューも入ってねー。ノードは動いてる。VI です。可能性としてはパスを通せばいいのかな。チルダーション、ノードのスーピン。エルスでノートパスが入って、 うまくいかない。TSC は、これで動かえるんだけど、じゃあ PNPM あとタイプスクリプトマイナスグローバル。これで TSC。おー。じゃあ TSC マイナス OK。TSC タイプ点 TS。これでキャットのタイプ点 AS ができたか。OK。で、ノーブル行けば行くから、あとは VS コード。ターミナルで、もう一回 TSC タイプ点 TS。ノードタイプ点 JS。来ましたね。つまり、グローバルに入れれば大丈夫ってことか。じゃあ、やっと戻って、これでこうやってこう続けできる。
Welcome back. So in this task, we're going to get an idea now of how we would start to write our type checking in JavaScript with the help of TypeScript. And to do that, the first thing we're going to need to do is to head over here now into our TypeScript folder and create a new file which has the extension .ts on the end. So for this, we'll just create a types.ts. And that create a TypeScript file for us. And just to make sure that we know that's working, we're going to log out, of course, a hello world.
Hello world.
And then we'll go ahead, head over to our terminal here, make sure we're in the right folder. And that we want to do is we want to run tsc types.ts and hit enter. What you can see that's going to do for us is create a types.js
戻ると、このタイプ JS ができている。
folder with all of our transpiled code inside. And we can simply run the JS file coming into the console and just simply doing node types.js. And that's going to print out our hello world. So,
このノードテイスタイプで、デバッカーが動くのはあるけど、まあ、グローバルとは動いた。
Back over to our types.ts now. And the way that we declare our type is very simple. We use a standard setup of a variable, so we can use let in this case, and let's do a string. Standard way of declaring a variable, let my string, but before we do our equals, we need to declare the type. We use a colon and then the type. In this case, it's a string, and then we continue on after that with our equal sign, and then we can have a standard string saying hello brave new world. And what we can go ahead and do is just log that out. My string. And again run our tsc types.ts.
次は基本。タイプスクリプトチュートリアル。 マイ、してあるいや。イコール、ヘロー、タイプスクリプト。これです。コンソール、ログの、ナイストリー。で、これを、タイプ。あれのふうでね、であったんだ。タイプスクリプト。レッド、マイ、ドリン、アイ、エンド、コロン、タイプとしてストリング、コール、ヘロー、タイプスクリプト、コンソール、ログ、ナイスライン。で、これを、ノード JS、ヘロータイプスクリプト。バーマジになるんだ。まあ、問題は、綺麗にできた。
To transpile the code. Once that's done, we have a look over in our JS. There we can notice in the JS file we don't have this TypeScript of declaring an actual string, but we do have a standard string being declared here. So hopefully once we run node types.js, we're going to get hello world, we get our hello brave new world as standard as well. Back over to our types.ts. If we were to perhaps try to, even though we've declared it as a string, we try to actually write a number, say 42. Let's see how.
エラーが出るよねっていうのを解説するわけね。
What we actually get.
Type numbers。つまり、例えばこう、78、まあ、42で今だけど、42のセミコロンのスラッシュ。エラーがなることを確認する。エラーって、type number is not the same as type string.
Get here in the console, there's an error. Because we've declared it as a string, we get an error saying type number is not assignable to type string. So there we can see a demonstration of the way that TypeScript is picking up these errors right there in the actual, at the time of compilation, as opposed to the runtime. So we're picking this up nice and early, but we can see somewhere else in our code where we might be perhaps using a wrong type, we know that we're going to need a string type, and that string
蓋が違うって怒られたっていうことね。
should be able to compile down perfectly.
ということは
which it looks like it has done. We can simply run node types.js and we get hello world and 42. Sometimes the style that people prefer to take is to just declare the type above and then down into the code, different places, they'll actually place the value on the actual variable itself, where we can just do my string equals hello again. And again, we shouldn't have any problem with this once we transpile it.
なるほど。ストリングでここで一回区切り。マイストリングイコール。Hello TypeScript again。で、当然同じように と、my_num。これは多分、number イコール、これはもちろんダメでしょう。これでコントロールセーブして、コンパイルすると、let my_num タイプスイングだから、ここも3とすれば、問題なし。じゃあ、ナンバーはできる。インティジャーとかはできるかな。
こんばんは。
こんばんは。今はちょっとタイプスクリプトをやってます。インティジャーだとダメだ。コンソール点ログ。
ティーペスクリプト、ナウイですね。
ですね。まだ基本だけですけどね。これでコンパイルできれば、OK。ノードで起動すると、エローだノード。OK。じゃあ、ビデオの続き。
And run again node types.js. We get hello world and hello again. So it's totally fine to do it this way, but all we need is a colon and then the actual type itself. But the way that you'll most commonly see it is directly seeing an equal sign and then an assignment of the variable with its actual type on the same line. So the same way that we do this, we can potentially assign numbers. So we can have let my_num, which we want as a type of number. This is pretty obvious. We can actually make that 42. And then again, if we transpile the code by running tsc types.ts and then run our node types.js, we need to log that up. Transpile it again.
セミコロン書かないか。いや、混合してるな。
And we get our 42 printed out to the console. After a while, after we keep transpiling the code down with that tsc command, it can get a little bit tiresome. So we can actually get TypeScript to actually watch this file permanently, so we don't have to keep doing it. So anytime any changes are made, it automatically transpiles for us, simply with appending -w onto our command. So we
サ
can
ン
go
プ
on
ルコードっ
types.
て数字に40に使うこと多いですよね。
あれですかね。そういう なんかの元ネタがあるん
And
でし
that'll
ょう
enter
ね。
into watch mode. So now we go starting compilation in watch mode, and it's waiting for file changes. So we go ahead and do a new one now, or we can maybe do let's my bool and just declare my bool to actually be a boolean. And let's just say for this sake we want it to be true. We can go ahead and log out the value of my bool, and hopefully that should be transpiling directly for us. So if we go over to our types.js, we do get console log my bool that's already been done for us. So if we open up a side-by-side terminal here and go ahead and do our node types.js, we get our true at the end of the statement as well. So again,
タイプサーバー入れた？ ESC いらない。ちょっと待って。まあ、いや、こ
TS
の辺ちょっと待って。
or we can maybe do
どういうことやってるその前。
C command. It can get a little bit tiresome, so we can actually get TypeScript to actually watch this file permanently, so we don't have to keep doing it. So anytime any changes are made, it automatically transpiles for us, simply with appending -w onto our command. So we can do our types
-w
.ts and then -w, and that'll enter into watch mode.
なんでね。-w、-w。うん。ターミナルで、-w、タイプで ts。ほうほうほうほうほうほう。マイナスウォッチモードを使えっていうのが使える。そして、こうしてこっちに、ノード、タイプ、ドン JS ってやればいい。アンディティラー。
勉強用のサービスといえばなんですが、OLAD、オンリネ、レアーニングって使ってます？
いや、知らないです。そんなのあるんですか？オライリって言うと、今で使っているのは、あらゆる、有料ですね。そこまでお金出せないかな。これやってると、プライシング。
はい、年99です。しょぼーん。
向こうのやつって読み放題とかあるんですけどね。多分、ソフトウェア企業でこういうのをやってくれたらすぐやるんじゃないですかね。月49ドル400。やっぱ高え。やってないですね。これはちょっと使えないですね。でこっちではやったから、レッド、マイ、ルール、フォロー、
裏技使うと年99にまで下がります。確かにそれでも高いですね。
裏技って言うともしかしてアカデミックライセンスとか、そういう感じですか？でも高いな。
はい、そんな感じです。
コンマ、マイ、ルール、エラーなし。ノード、タイプ JS。行く。
Permanently, so we don't have to keep doing it. So anytime any changes are made, it automatically transpiles for us, simply with appending -w onto our command. So we can do our types
-w
.ts and then -w, and that'll enter into watch mode. So now we go starting compilation in watch mode, and it's waiting for file changes. So go ahead and do a new one now, or we can maybe do
確かにオライリーとか気になる
eyeball and
な。
just declare myBall to actually be a boolean. And let's just say for this sake we want it to be true. We can go ahead and log out the value of myBall, and hopefully that should be transpiling directly for us. So if we go to our types.js, we do get console log myBall that's already been done for us. So if we open up a side-by-side terminal here, and go ahead and do our node types.js, we get our true at the end of the statement as well.
ここまでできますと。
So again, tsc, the file itself which you want to watch, which in this case is types.ts, and simply -w to enter into watch mode, but it's already been done there. Finally, for this task, we'll have a look at the, let's separate this out so it's a little bit clearer for us here. We can use the any type here.
確か無料で2週間使えますよ。ってなんか営業みたいになってるので落ち着きますね。
いやー、2週間じゃ足りないでしょう。ワラリーですから。内容濃い
Use the any
し。
type here. And we want that to actually be of type any, and that can be any particular value, be it an array, and if we log that out and do our node types.js, we get printed out an array. It can be any type of value here.
まあ、エンジンでやるんだ。
A number,
まあ、エンジンは何でもいいってことだろうな。
-4. And again, the same thing with the numbers here. It can be a positive number, it can be a negative number, it can be a float, or something like a hexadecimal, so something like that would also be
0xF03。
valid also.
16問大丈夫ね。
Great stuff. So we've now covered exactly
Audio
how to
debugger.
actually declare our variables with types in TypeScript. And we've looked at some simple types as well. In the next task, we're going to have a look at some other types, such as arrays, unions, void, null, and tuples, and start to actually play with it a little bit more. So we'll see you there.
まあ、ここでは JavaScript やってた、ああいう安心感はあるかな。
Welcome back. Let's go ahead and carry on looking at some other types. One of the types we can look at is arrays. And one of the cool things we can do with TypeScript is we can actually set it to a type that we are expecting to receive. So if we're expecting to receive an array of strings, we can declare it that way. Or an array of numbers, or an array of booleans, we can set it that way. So for example, if we set a variable here, string array of type string, and then the array sign, that's one way to
あ
actually
と
do
ね、
it.
アレイタイプにすること
We
で
can
す。
simply have that equal to an array of strings,
まあ、エニアレイが使えるってのは別にいいのか。
and this will all be valid for
なるほど。つまり、ここまで。もう一回。
TypeScript, as long as it's an array of strings. Same thing goes for
つまり、str アレイ。
主さん本職のプログラマですか？
もっとですかね。うつで休息しちゃったんで、今は休んでます。だから、前は PHP とかが古い、知識が古いんですよね。Java とかも 2.4 とか 1.8? もう Java 18とかやってないんで。今それでリハビリがあって新しい知識を覚えているっていうところですね。あれ。問題なし。そして、 ノードでタイプ JS というなると3フレームが出ると。
For numbers. So if we say
で、
let's
ナンバーレイの場合は、
リハビリで勉強って生粋の技術者って感じですね。
なんか物を覚えるって、力がつく感じで好きですよね。自分が経験値積んでレベルアップする感じで。
type number and then the array
こ
sign,
の同じパターンは一緒と。
we can then make that variable.
でも、そうすると、やっぱし、エラーが出るかどうかをチェックしたいところだね。イコール42マイナス 0.5 コンマベース3文字列3とコンソール点ログのナムアレ。おー、見事エラー出た。文字列マッチングファイルチェンジ。ここは文字列だからダメですよと。こうすれば、ノードタイプ点 JS。で、JS を見ると、おお、ここにもそのまま残すんだ。消してくれてもいいのに。
An array full of numbers, which will also pass. So we get no issue here. But if we try to put a string inside of this array, what's going to happen? We get thrown an error here. Type string is not assignable to type number. So TypeScript knows what it's expecting here. Same thing for booleans. If we did, for example, we could have a bool array.
まあ、これもスキップするの入れ
Could
て
be
も、
equal to
ブルー
boolean
って変わるしかないよとい
array
う。
sign, and again,
いや、
it's expecting an array
Yeah.
full of booleans.
ブーリアンならば、ブーリアンもっと大変だろうけど、例えば、ブーリアン大括弧イコールブルーパルスヌルをどうだ。ほら、そこら辺は入るじゃん。コンソール点ログ。あれ。ヌル。アンディファインド。ああ、これ A が邪魔やね。とすると、ヌルとアンディファインドも一応入る。ブールには。4値やね。
Doesn't matter the length, matters the values inside of the array. Another really cool type that we have when dealing with arrays is the tuple or the tuple. And the way that it works is as long as you're clear with the actual values and the quantity of items in the array that you need, that you require for your array to adhere to, then you can set that out with an actual tuple. And the way that you write that is something like, we can declare a variable, so we call it string num tuple.
ダブルか。
and we make that equal to an array, we can go ahead and then specify the value types as we like to see them in the array. So you can be very verbose with that. So you can say string, num, number, and even say boolean. Well, if we said string num tuple, so let's keep it without the boolean for
テーブ
this.
ルでそういう形でで
And
き
then
る
we
の
make
か。
that equal to, we have to adhere to the same structure. So it has to keep the order.
例えば、次はタプル。マイ、タプル、コロン例えば、ストリング、ナンバー、コール、効果、ララ。はい、ララ。ほんま。汗人。コンマ33みたいな感じにできるってことかな。タブ。こうやってやると、じゃあ、ここでこれが、例えば、ストリングになってるけど、16とやると、これエラーになる。エル、デン、ティン、汗人、こんな感じにすると、この側はダメよという。なるほどね。
So we could say a string, hello, another string, of course, world, and then a number, 42. As we can see down here, as soon as we adhere to that, the errors go away. But if we add another element, say 24, then we have obviously met the minimum requirement, but it needs to be exact. So we still get an error. It's not assignable. So it needs to be to the same length. Also, if you try and change the order, so if we still had like 2 strings and a number, but we changed the order, 1 number and 2 strings, and it's all in there, but it still has an issue because it needs to adhere to the order as well. So tuple is actually good if we need to, if we know exactly what order or types that we're expecting to have from our array. Let's correct that. So we can remove this error. So it'll be 2 strings. So we can have hello, world, and 42. Hopefully that'll remove our error for us. Close our array, of course. And our tuple is valid. Next we have the union type, which we would use if we know that the value of, the type of the value that we need could be of a number of different types. So let's say we have a function and we want to accept string type or a number type, we can go ahead and do that if we just declare a variable here, and then we make the type equal to string, and we just simply use the pipe separator to separate the types. That will actually accept any of those two types for the value that's set to my union. So even if we just left it here, and then later on we had my union is equal to 42, it wouldn't throw an error.
ユニオンタイプっていうのを作れる。で、my ユニオンコロン。まあ、そういうふうに、ストリングは、コンマ、リング。当然こういうふうにすると、イコール。やっぱローグレガシーとかして、1.0 みたいなことができる。この場合、どっちかだから、ユニオン is スペースの、ユニオン。セミコン。で、エラーはなし。使えるよねっていう。ユニオン is ローグレガシーと。なるほど。
And if we made my union is equal to hello, it wouldn't throw an error. But if we go ahead and make my union equal to, say, a boolean, we haven't declared that value, so we're going to get an error. The boolean itself is not assignable to the type string or number. So the union type is really cool for where we want to allow something. We may have a function that accepts a number, but maybe a string may be passed in, so we can accept a string and a number, and then we could run some kind of parsing or some kind of logic inside of our function that accepts a string and a number as a type, but potentially checks if the value passed in was a string, then it might be able to convert it over to a number, or vice versa. So that's sufficient for this task. In the next task, we're going to have a look at some other types, like void, null, and start having a look at functions so we can start putting this into practice to kind of see some of the use cases that we might actually have for all of these types and type checking. So I'll see you there.
ファンクション、ボイドヌル、アンデバインド。こと関数やね。
Welcome back. In this task, we're going to get a bit of a hands-on with using TypeScript in how we might use it in real life. So to do that, we're going to open a new file here. So click on new file here. Let's just call it functions.ts. And then we can start to actually have an understanding of how we'd use TypeScript in the real world. So if we declare ourselves a function, I'm going to use the ES6 syntax here. So let's do const sum. It's a very simple function, which we're going to make as an arrow function, which would normally take in, let's say, a number and num2, and simply returns out num1 or num plus num2. Obviously, as we know from regular JavaScript, this is a very simple function. But the way that what we can do with TypeScript here is we could actually be quite flexible in.
オリジナルなんだろう。タイプスクリプト安全性がないよね。ファンクション TS。コントロール C の ファンクションで ts と。さて、関数について。さて、コンストサムイコールナム1コロンナム。多分これくらいできるんじゃないとちょっと困る。ナムコロン。これをアローファンクションでイコールの、オフにしないといけない。ナムプラスナムにセミコロン。これくらいぐらいをできなきゃ。で、コンソール点ログのサムカッコ8コン9。こうすれば、ノードの音、ファンクションズ JS ができて、17と答えが出る。
Expecting specific types from arguments being passed into the function, and even going as far as to expecting return values from the function as well. So we can be quite verbose in that manner. So we could say num here, and we do it exactly the same way what we did before. We use a colon. We can maybe say we're expecting it to be a number. So it's just the same way. We could do the same with num2. We put a colon, declare the type, expect it to be a number. And although it starts to look a little bit confusing, it is fairly simple. We do the same thing with the function itself. Before we do our arrow and our return bracket, we just, as we're sort of declaring the actual function itself, we place our colon here, and then we'll actually type in the type of return value.
このファンクションの型も定できると。
Value that we're expecting to come out the other side, and in this case again it's going to be a number. So let's go ahead and cancel this here. So Control C, click on this terminal here and Control C, and let's go ahead and watch our new file, which is called functions.ts. So we're going to do tsc, and it's going to be functions.ts. We're going to do in watch mode -w, so it'll keep watching that for us. And as we know, it creates this functions.js for us over here, and we can see it's just returning out a regular function here. So if we then potentially want to log out, let's say sum, and we pass in 1 and 2, we run node functions.js, we're then going to get out our 3 results as was expected. But if we passed in, let's say, a string here, we obviously get an error before it gets to that stage. And if we run node functions.js, we still get this, but it's concatenating for us. But what was happening here is we're getting an error in the compile stage here. Argument type of string is not assignable to parameter type of number. As we mentioned earlier, we might imagine a situation in which we might somewhat be expecting a string or a number to be passed into a function. So if we maybe call the second function here sum2, and then we have a num we're expecting that to be a string or a number, but only a string or a number, we can potentially use a union type here, and it works exactly the same way as it would work outside of a function.
あ、そっか、さっきのタプルを
We
使え
can
るんだ。
declare string, use the pipe symbol, a
ミニオン
number,
して、
and then we can also do again num2, and we declare the type for that the same way. We're declaring that we are expecting a string or a number on that as well. But we want the return value potentially just to be a number. We can still handle this elegantly with TypeScript. And if we wanted to do some kind of type checking inside the actual function itself, we could do that. So we could create some logic where we check for the type of value from num1, as we know this is regular JavaScript here. So if we say type of num1 is equal to a string, we want to be able to catch that. So we can use a ternary here, and we can take num1, which is actually num, not num1.
Sum 2 ゴールnum1 ストリングまたはnum に同じストリングはnumローファンクションnum1 ゴールタイプnum1 イコールストリングのハテナ
And we can go ahead and take that num and make it equal to the integer that's actually parsed from num, or else do nothing. We can go ahead and do the same for our second example here.
そういうことか。num イコールで代入しないから、
and if we are expecting or receiving any strings as values or arguments being passed,
この場合、代入文が式と代入式になるわけね。num1 イコール例えばナンバーnum1 これできるかなそういうやつはできない。じゃあnum1プリミティブならできる。コロン、ダメだ。パースイント使うのが一番安全と。で、同じように、 これをやると、ナムにも同じように、ナム1イコールはいらないんだな。で、リターン、ナム1プラスナム。コンソールログ、括弧34、3、3、2、ベース。3、コンマ、両方とも文字列にしても、実行が、17の3に7と出てくると。こういう文字列がカーセンターに入るからだね。OK。ビデオに戻ると、
In, we could create this logic that takes care of it. And then when we do our return, we can now do a simple num plus num2. And that should now pass the requirement of receiving a number as a return value type, even if we go ahead and pass into our function a number, say 42, and a string value of a number, say 42, then we no longer get any errors in the console here. And if we run node functions.js, then we get 84, which
じゃあ、もしかして、34は簡単。だ、ここが、4の、マイナス4の場合は、多分2の0でも効く。マイナスマイナス。数字じゃないわ。なんと、数字じゃないよと出てくる。
is 42 plus 42, with this string actually being converted over, which should also work in reverse also. We also have a type called void, and for this we will copy over this and we'll make it sum3 just for demonstration purposes here. And let's... Typically the way we'd see void used in the real world, it's not very often. What void is actually doing, it actually means it equates to... It's the opposite of, say, something like any. Any means any type.
const sum3 じゃなく、コントロール C のボイドを返すようにする。おう。じゃあね、こっちサム3。サム3イコール、うん。サム3でボイドだから勝手に返しちゃいけないわけね。リターンナムしてますなのに、ボイドは値を返さないから、リターン文もいらないってことか。 ゼロエラース。アンディファインドは与え替えるんだ。だって、こういうならばタイプじゃない。ファンクション JS を見た方がいい。あんまりリターンは返せないからいいか。
type of type, and void means of no type at all. So therefore, if we put void somewhere like here, it's usually symbolic to the development team that this particular function doesn't have any particular return value itself. So even if we go ahead and do sum3, we're going to go ahead and get an error here in the console, because obviously we're returning num plus num2, and in this case the type void is supposedly meaning it's not expecting what's returned out to have any type at all. So if there's any return value at all, then this will always fail, whether it's a string, any type whatsoever, or if we returned an array, or if perhaps
いや、もしかし
we
て、
returned an object,
値が変内な
we'd
らい
always
ける
get
のか
this
な？
error. If we turned a number, we'd be getting an error. So we might normally use it to send some kind of message to the developer for them to actually see in the console. This is fine, and even taking the return value off doesn't break it, because it's not expecting any return to come out of this particular function. We do have null and undefined, but there's also not much you can do with them. So for example, you can have const n, which is of type null, and the same with undefined. Which is of type, say, undefined, equal to undefined. So they have their own types, but they're not much useful on their own. This is really great work. So we've been able to see here how simple it is to start using types inside of our functions, using it and being able to run some type checks inside of our functions to check the types of the arguments or parameters that are being passed in order to make our code a lot more robust. And we've seen how easy it is after actually our function brackets, that we can easily just chain on this colon and then declare a type of return value that we want to see returned out of the actual function, to keep strictness on the return value even of a function. In the next task, we're going to have a look at enums. So I'll see you there.
次はenums。
Welcome back. So it's now time to visit one of the more advanced topics in TypeScript, which is enums. Though once you get the hang of it, it is pretty simple. So to do that, let's create ourselves a new file, and let's just call it enums.ts. And we can describe an enum as a way for us to give more friendly names to a set of numeric values. And the way we write an enum is quite simple. We just simply write the word enum, and then we set it's almost like a custom type that we're actually giving. So normally we declare the type as a string or a number or a Boolean. In this case, we name it ourselves. So let's just say, for example, colors. We open the curly bracket, and then we are more or less passing in what you would imagine to be the keys
シンボルだよ
of
ね。
an object literal. So let's just say, and we do that conventionally in all caps. So we can potentially do red,
まあ、キャッ
blue,
プにするのは
green. This gives us a very easy way for us to remember
例だな。
the references to our colors later on in our code.
まあ、ここは同じようにやってみましょう。ニュース、イーナムス、TS。サンプル。で、こっちも、イーナムスって言った。ニュー、イーナムス。S。まあ、大文字から始まるのが慣例だね。V、スペード、アート、ダイヤ。まあ、基本でしょう。グラフ。コンソールっていうの。こういう風に出せるが。ゼロが入った。じゃあ、スペードってここまでやったら、エラーが入ってるな。スイーツのスペードは。そうすると、
We mentioned that we're giving more friendly names to a set of numeric values. That's because behind the scenes, which we're going to have a look at it in a minute, what TypeScript is actually doing is giving this a value of 0, giving this a value of 1, and it increments as we go down. So it's storing those references to these variable names that we've actually given. So we can simply go ahead and declare a variable, let's say my color. We want that as a type of colors, which we've already set here. And we'll set that equal to, and then we can really just refer to our enum as an object literal. So we can just go ahead and do color.
レッド S コロンスイーツ。スイーツイコールスイーツ点ダイヤ。S をカッコ。コンマの S と。これを実行すると、 2が順番に数値がバインドされるってことね。
or colors, dots, and then TypeScript actually gives us the reference to the various colors on there. This can help us to organize our code and to keep it pretty strict if we know that we want to pass in colors .green in this case. Let's have a look at a different example to see how we might actually use an enum in a real life example. Let's say, for example, we wanted to create some kind of program that prints a message depending on what day of the week it actually is. For example, we may have 0 to 6 in our database, with 0 representing Monday and 6 representing Sunday. Now, a way that we can actually build that as an enum is we could simply declare an enum here and then just call it potentially days, and then we can just type out our days in all caps here. And now let's say we wanted to have some kind of a function called getDailyMessage, which is a function which takes in a day, and this particular day is of type days that we have our enum. And we can maybe build some kind of a switch statement inside here that takes a look at the actual day that's actually passed in, and depending on the day itself, we can actually represent that simply by typing in days dot, and then we get all of our days. This could really help simplify our code. When it does actually equate to a numerical value, but let's just say, for example, it's a Monday. So let's say it is a Monday. We may want to return a message saying get a coffee and get busy. And alternatively, we may potentially build a case where it's maybe Friday. And in this case, we may want to return a message, push through, only one day left. Now, if we simply log out, I suppose before anything, if we just log out days itself, and let's go ahead and set this up. So let's cancel out of our previous, and we're going to type in tsc enums.ts -w here to watch our new file here, and that'll also create an enums.js. Now if we simply run that, so we do node enums.js and we're logging out days, we can actually see what's happening here. So inside of this object, from all we've done here really is declared the enum days and then given it these values. TypeScript's gone ahead and done a few handy things for us. So it's actually made a reference to these keys here to the numerical values, as we said. And if no numerical value is specified, it simply increments starting from 0. And what it's also done is made the handy reference, just in case potentially we may just have the
れそうって。まあ、これは、スイーツをどうなるか。スイーツ。これはまあ、何、ネームステース。ファンクションで、バースイーツ。ファンクションスイーツで、スイーツ、スペルイコールでスペル。うわぁ、わかんないけど。よし。こういう形で、実際。
numbers or the numerical values, and we want to find out what string that equates to.
まあ、中身はあんまり考えなくてうまくいってくれた。
TypeScript has gone ahead and made a reverse reference for us. And we can see the code here in enum.js. If we just ignore the first one here and have a look, it is a little bit on the advanced side, but all that's happening is this is an immediately invoked function here. So all that's happening is if there is no days, then days is made equal to this object, an empty object, or it's initialized as an empty object here. And it's making both of these two references just in one line. It's making days, and this equates to a 0. So day 0, and it's setting that to Monday, and at the same time, it's setting days Monday to 0. So it's just a little bit of a deep dive here to be able to see, but essentially, it's making these numerical references to our declared so-called variables, which makes it a lot easier for us to keep control and to write our code. And it just reads a lot better and keeps that control. You never know when potentially, if we were just using strings, you don't know how someone else has spelt it. Maybe you use the European spelling of potentially the word color, which has a U in here. You never know. So anything could change. This really simplifies our code and keeps it really controlled and allows us to be able to write a lot better looking and more verbose code. Really great work. So in the next task, we're going to have a look at interfaces, and that'll be how we can actually control the shape of an object that we're expecting to be passed into a function. So see you there. Welcome back. So in this task, we're going to have a look at, so if we think about a standard JavaScript object, we know that it's no more than a map of key value pairs. An interface then is a way for us to define the shape that an object can take. So if you have a function, for example, that accepts an argument that should be an object, if we want to know what the actual shape, or particular shape the object should take, then we can specify that particular argument or that parameter takes a type of a particular interface that we define. So an interface tells the TypeScript compiler the property names that an object is expected to have, as well as its corresponding value type. So it looks just like an object, but it only contains information about the object properties and their types. So let's create a new file here. We'll call it interface.ts.
Now let's
take a very simple example which looks at
ちょっと、じゃあこっちもやって、良いだけそこ。enum.js。じゃない。インターフェースについて。これは OOP の基本のところからだね。
a person state. Now, the way we set an interface up is quite simple. We simply type interface and then we declare it with a name. Convention is to actually capitalize the first letter, so we're going to call it person state. Looks like an object, and then we're really just going to say what parameters we're expecting the object.
インターフェースの型になるから、パーソンステート。当然。
To have at a minimum. And this one we're just going to have name. We're going to expect it to be a string. And we're not putting commas here, so we can put a colon here, or a semicolon rather. And what we're going to do is include the boolean is hungry. And that's going to be a boolean as expected there. So interface name that we declare ourselves. And again, just open our curly brackets. And then we put in our
name is boolean。
key value pairs, the key, the name of the key, and the value type that we expect it to be. So if we set up a function here, say show states, and that's going to be equal to a function, obviously. And the function itself is going to take in an actual person. The person is going to be of a type person states, so it adheres to the person state interface. This is going to be expected to be an object. We'll create the object in a second. So what we're going to do is simply return person.name, and we're going to just concatenate it, put a string here. We'll have it as person.name is, and then we'll simply throw in a ternary here, and we'll just say person.is hungry, and if it equates to true, we'll simply return hungry, and if it equates to false, we'll simply return not hungry. Pretty straightforward. So let's go ahead and create our person. Simple variable. We'll call our person Anakin. And it's going to be equal to, so Anakin itself is going to be of the type person states. And now this is actually going to be equal to an object. And now we just design our objects accordingly. We can do Anakin, of course, Skywalker, and we are doing our object.
Is hungry. ダメだ。ts マイナスインターフェース。インターフェースだからダメなのかな。うん。ファンクション。ピュアステート。イコロン。2.2 プラススペース。まだ眠い。プラスカッコの。ね、半分にしたわ。イズハングリー。いい点か。イズハングリー。はてな。ハンは、なんだ、マッチ。意味が強い気がするけどいいや。こういうふうにやって、コンスト、アナ。イコール、えーっと、と、銀コロン、パーソンです。イコール、プラスというあれになるから、これできちゃうんだ。はい、is そしてコンマか。コンソールテンログ、アナキン、や、小、パーソンメッセージ。さて、こっちをやると、ノードインターフェースです。あれフォンド 0S is hungry. まあ、ここまで出るのは分かってる。
So we need our comma, and we're going to need an is hungry property here, and we're going to make it true. Now we're going to log out the result of that, and we're going to pass in our object, which is Anakin. Anakin is a person, taking the interface of person as expected here, and we've placed is hungry as true. So let's sort this out now. So let's Control C here, and we want to start following our new file here, which is interface.ts. So we're going to do a tsc interface.ts-w to follow that. Let's clear this console here. And now we simply want to run, if that's actually created our file, interface.js, we want to run node interface.js. And we should see in the console here, Anakin Skywalker is hungry. Now, if we had just a standard object, we have like Anakin, which is equal to an object, and then we only require that it adheres to this person state interface as it's passed into this function. Then what happens if we just have an object which has other properties on it, say children, which could be potentially equal to an array, Luke and Leia. We don't get any errors here in the console, whereas if we obviously if we declare that this adheres to a person state interface, at this point we do get the error. So we could obviously just have our objects, but as required when it's actually passed into this, function here, is that it meets the minimum requirements of the person state interface, i.e. if one of the properties that is required according to the interface is of a type that's different to what's required as set in the interface, let's say is hungry was equal to something like 0, then this breaks our interface requirements, because the minimum is that it has name and is hungry, and is hungry is obviously required to be a boolean, so a number doesn't pass in this case. And if we do false, we tried true last time, and we lose our error, still a boolean. And if we run this now, Anakin Skywalker is not hungry. We can also specify inside of our interfaces if we want any of the properties to be optional simply by putting a question mark at the point of the key of any sort of property here. We could put a question mark here. Then in this case, if it's not present, then at this point we also don't have any break in our code as it's being compiled here. It still passes because this is optional and it's not passed in. We only have name and children. So that's interfaces, very powerful way for us to set the shape of an object as we expect it to be in our code. The next task, we're going to have a look at classes in TypeScript. Hope you enjoyed this one and I look forward to seeing you there.
待って、クラス。
Welcome back. So this task we're going to tackle classes in TypeScript. It's a bit of an advanced topic, so feel free to rewind this section if you need to. Let's get straight down to it. We're going to need a new file. And let's make it classes.ts. Now in here we're going to write a simple class called greeter. Our greeter class it's the same as it is in ES6, so we start it with class greeter. And we're going to put three things in this. We're going to put a property which is going to be our type of a greeting, which we're going to set that to a type of string. Second thing we're going to have on here is going to be our constructor. And our constructor is going to take in a message, which is going to be of type string. And it's going to set this dot greeting to the value of the message that's actually passed in. So we've got a greeting type of string, constructor, and we're going to have also a method greet, which we call it simply returns hello plus this dot greeting. So whatever greeting we've passed into that particular instance. Let's now create an instance. Let's call it greeter. We'll make it equal to a new instance of our greeter class. We'll pass in a message, which is going to be hello, and we'll just do it as how are you. And now we can simply log out greeter dot greet with our message on it. Okay, so let's get this set up here. We'll run our TSC on our classes file in watch mode. Get our classes.js, which we want to run here, classes.js, and we're going to get our output here, hello, how are you? The key point to note here is that all of our members of the class here are actually set to public.
はい、こんばんは。ちょっと疲れて半分寝てますけど、まあなんとかやってます。これはインターフェースの方などに入れちゃおう。名前を OOP にして、
これは何の言語ですか？
これはタイプスクリプトです。あれですね。JavaScript に型をつけて、あれです。クラス。Greetings。
なるほど、知らないやつだ。
今は本当に最初のクラスとかそういうのをやってるところですね。あ、プリック使うんだ。グリーター。 かっこいらない。
So this doesn't actually break anything. We can either have it or we can completely remove it. This works fine.
グリーティング。ファブリック、グリーティングス。グリーティング作るのか。トランストリング。
オブジェクト思考ですか？
ですね。今、クラスでオブジェクト思考の基本のところをやってます。学校メッセージ、ストリングスは、is, greetings, イコールメッセージ。でメッセージで実際にやるのを、メソッドがグリート。コンソールで、リターン、リターン、ヘロー、プラス、ディスのグリーティングス。これいいのかな？こうすると、G イコール、ニュー、グリーター、カッコの、ヘローの次に進むメッセージが入る。そうすると、コンソール点ログの G 点グリート。これで、来て、ノードの OOP の JS。Hello, how are you と出ると。
気になったことを言っていいですか？
はい。
The second point that we need
何でしょ
to
う？
consider is the
はい、どうぞ。
映像の取り込み範囲広すぎませんか？
フルディスクなので、広いですよね。画像が全部見たいんでやってるんですけど、見にくいですか？そうですね。フルディスクでやってる、ディスクトップ全部やってるんで、ちょっと見にくいかもしれないです。
concept of inheritance, and if you've worked with any other
3メー
object
トルにして全画面じゃないと文字が見えない。
the concept of inheritance, TypeScript supports
Ah.
inheritance patterns, in which a subclass can actually inherit from a
そう
base
かもしれないで
class.
すね。じゃ
There
あ
are a
ちょ
few
っ
points that we really
と、
want to keep in mind regarding to the TypeScript way of actually doing classes and
ただ、
inheritance. Is
ブラウ
the
ザ
first
の
thing
画
we
面
really want to think about is the use
と、
of
別に変えろってことじゃないです。
this
あれは見に
super
くいん
method,
で、
which is
このままにして
available
ます
for
ね。
us inside of the constructor function. If a class is actually a subclass or is extended from a parent class, then it has obviously access to the constructor function. It has to call super in the constructor function body. So if we use the common example of animals,
その方がやりやすいならそのままで。
class here.
じゃあ、すいません。このままでいきま
Let's
す。
just comment this one out. Let's create a new class here called animal,
お、基本できた。
and let's give it a name of type string. let's give it a constructor function, which takes in property, the name of type string, and let's then have that initialize with this.name is equal to the name which we're actually passing in. Let's give it a method move, which is going to take in a distance in meters, which is going to be of type number. We're going to set it as default value equal to 0. And inside of that, we're simply going to log moved plus distance in meters plus meters. What we can do is we can then go ahead and create another class which is going to be an animal, say a snake, which actually goes ahead and
エクステンドを使う
extends
のね。
the base class animal. Now we have access to this constructor method, which we can have potentially to take in a name of type string.
こうやってなくて
As
見
we
えるとするけど
mentioned, inside of this constructor, we have to go
まあ、ス
ahead
ーパー
and
で
call
残念。
this super method. That actually clears all of our errors here, and we're going to call it with name. And so this illustrates for us this point that we have to actually include this super call inside of an extended class. This class is extended from animal. The super call, as we know, calls the constructor method of the
まあ、
base
こ
class
れを
that
ス
is
キップしていく。ああ、いかん
being
か。
inherited from. If we remove this line, then TypeScript will give us the error. Constructors for derived classes must contain a super call. And it's telling us here what it actually expects here. So we're going to need that in there. We can override a method in the base class by creating another method on the subclass by the same name. So we can create another move method like we have up here.
ムーブオーバーライド。
And we can go ahead and expect to take in a distance in meters in here also. And just for the sake of the snake itself, we can set that to 5. And we can go ahead and call super, which is our base class, and then
ああ、ス
append
ーパークラスなのか、
with
この場合
the
は。
method itself and pass in the distance in meters, which we'll be expecting. So now if we create an instance, let's say snake equals a new snake, and then we pass in a name, Slithy. We have no errors here. And if we run our node on classes.js,
あ、何も動かないね。
we need to obviously log that out.
マリー。
Then we get an instance of snake named Slithy, and we can simply log snake.move. And so
Zero error
that gives
です。
us
まあ、アンテナ出る
moved
ときか。
5 meters. So it overrides the original method simply by calling super dot and then appending it with the method in the base class. This is fine, but what if we want to protect our classes from being accessed in this way? So from outside either by instantiating or by accessing these methods. TypeScript allows us very strict ways to control how we actually set our members of the class to private or to protected, which have various features. So if you join us in the next task, we'll have a look at private and protected modifiers and how that affects our code. So I'll see you there.
だって今のところまでちょっと実装してみましょう。
Welcome back.
今のところ実装すると、クラス。アニマルだ。これペットでやった方がわかりやすいよね。ペットは、名前を持つ。コンストラクター。メッセージなく、this name equal だ。ね、散歩って英語なんて言うんだっけ？僕でいいや。ウォーキング。メーターズコロン。ナンバー。リターン。ムーブド。メーターズ。メートルと。メーターズメートル。散歩したと。で、デフォルトバリューイコール0。コロンストリング。こんな感じなわけか。そして、あれエラーで、これを継承すると、スネークペット。イコール、エクステンズ。で、これも、ウォーキング。メーターズ。ナンバー、イコール5とできるとすると、コンソールでいいのか。スーパーでウォーキング。ウォーキングのメーターズ。ここまでは簡単。レッド、マイベッド。イコール、ニュースネークベッド。 てろが。こんな感じにやると、コンソール点ログの iPad。iPad の大きな散歩ができると。こういう色にすべきなのか。おお。合わせればいいってことね。そうすると、ノードの OOP.js で、ネーム0が5メートル散歩した。これ来た。this 点ネームプラスは、プラス、さて、続き。
In this task, we're going to continue with the work that we did in the last task. So if you haven't had a look at that, go and have a look at it first. We started working on classes. And in this task, we're going to have a look at classes as it pertains to protecting those classes from being accessed outside of those classes. We already have created this class animal, which takes a name constructor and a move method. And we have already discussed that by default, all of the members of a class, that is the type, the constructor, and the method here, in this case, are all actually marked as public by default. And as such, we don't need to actually label them public as we would in some other languages. So if we do want to actually mark any of these members as private or protected, we would have to go ahead and do that. And it works, private and protected work in a similar way in that they can't be accessed from outside of the containing class. So for example, if you wanted to put private before the name type here, and if we were to potentially create a new animal type or an animal instance here called, say, kitty.
ここで、プライベート。
Which is equal to a new animal. And we'll pass in cat as a name here. The name which should be as type string here. And let's say we wanted to access the name now. Kitty.name, which we're expecting to get back cat. But we won't be able to here. If we see the error, property name is private and only accessible within class animal, kitty.name. We can't actually access the name property here because it's actually been set as private. So anytime you want to access it just generally outside of the class, you won't be able to. So the only way we can actually access the property name, as it is a private property, is through using the super method inside of a subclass. So if we did have something like a class, potentially a rhino that actually extends our animal class, the base class, and we had a constructor. Inside the constructor body, we can go ahead and call super, which calls the constructor class of our animal class, or the base class, animal class in this instance. And we go ahead and call rhino in there. We don't get any errors, even though we're accessing this property, because we're actually using this super keyword. using the protected keyword gives us a bit more flexibility in that allows us to be able to use the members that are actually protected inside of the derived subclasses. So, for example, this Rhino class would have access to the protected members of the base class that it inherits from. So we could potentially do something like create another method here. If we wanted it to be get animal name, which simply just returns a string that just tells us that this animal instance has a name of
private working。じゃあもう一回。クラス。t x エンズコンストラクター。キティじゃん。スーパー。子猫ちゃん。とすると、マイペットイコールキティンスで、ウォーキング、なんすると、エラーは出ない。これで実行すると、ねえ、子猫ちゃん。プライベートで参照はできる。じゃあ、ここで、ゲット、ねえ、これは、このストリーム。アローファンクションを使ってるわけじゃないのね。ね、アレディリターンで、この名前は、プラスディステン。ねえ。入らない。こっち、ここでネームにプライベートに、だからここは、ここクラスからは見えない。まあ、その方が安全なのよね。だからそういうふうにしたい場合や、プロテクティ。これは、そうすると、iPad then、ネーム。これでできた。ファンクション守ります。こうしないためか。
this.name. then in this case, we're accessing it. Even though it's a protected route, we do have access to it. But if we change this to a private route, a private member, then we get the error. Property name is private and only accessible within the class animal. But if we change it to protected, then we don't get an error. We can go ahead and call this if we were to, let's say we just quickly set up a new variable here, which is going to be a new rhino. And then we do a
赤く合わせるんだ。
logging of rhino dot get animal name and call it. Hopefully we have no errors here, and if we run our node classes.js, then we get the output here from get animal name. This animal instance has a name of rhino. So this has been fine for us also. This works fine for us, but we still won't be able to do rhino.name.
それはできない。
We'd get flagged an error. Property name is protected and only accessible within class animal and its subclasses. So you won't be able to access it from the outside. So this works really well. The protected modifier is a really useful modifier for us to protect our code and to keep it strict and allow only inheriting subclasses to access members that we want to be protected. Finally, we may have something like a base class like animal here, which we do not want any code to be able to have the power to initialize an instance of apart from a subclass. So in that case, we can go ahead and protect the constructor itself, which will allow us not to be able to ever get access to creating an instance of the base class other than inside of a subclass. So subclass, a rhino, for example, in this case, because it extends animal, it can actually call super and create an animal inside of the constructor here, or an instance of an animal. But why are we getting an error here? Because constructor of class animal is protected and only accessible within the class declaration. So because we have new animal here, this is now invalid because we're trying to initialize a new animal here, which is not allowed because the constructor of animal is protected. So we get rid of that, then that's fine. A new rhino actually initializes an animal because rhino is actually an animal. When we call this super, we call the constructor of an animal, as we know. And this is fine for us because the constructor is protected and we have access through our subclasses, but never directly initializing outside of those subclasses. Really great work. So I'm really glad for the amount of work that we actually covered here. Hopefully you get a really good understanding of TypeScript now, and from playing around with it in your own sort of cloud desktop, what you have there in your own IDE, hopefully you've got a much better feel and can take the confidence of actually working with TypeScript going forward. In the next task, we're just going to have a look at some config settings that we'd probably see in a real-world project, what you're likely to see at work will be really handy settings for us to be able to have in our own personal projects also. But that's the bulk of the actual work in terms of typing. So I look forward to seeing you on the next task. Thank you.
Generating TS config has some important settings.
Welcome back. In this task, we're just going to organize our folders here for something that resembles a bit more of a real-world development environment. So the first thing we can do is to come down here, click into the first side of the terminal, and let's do a Control-C to clear that.
ここを止めて
And we'll clear our typing clear on the terminal here. We'll type clear on the right side of the terminal to clear those. So the first thing we're going to do here is just to get rid of these JavaScript files. So go ahead and just one by one remove the JavaScript files. What we're actually going to do is to recreate the JavaScript files. Just be careful not to actually delete your TypeScript files here.
一緒に作られてしまうなってい
We're
う
going
こと
to do
ない
it
って
in
いう
a way
話な
which is a
のね。
lot more organized. So, and I think just the classes one here. Classes.js.
プロジェク
Okay,
トとして
so
作
here
る
we
場合
have our
は、
four files here. Our five, including this types.ts down here, and they're all here on the root level of our project folder. So what we really want to do here is to generate a tsconfig file, and this has the settings in there, which you would typically have in the real world projects. And we can do that by simply typing at the actual root level of the project. So we can do tsc -- init. So to successfully create a tsconfig file.
TS コンフィグっていうのを作ることで、
In here seems like we do have a types.js.
じゃあしょう。こっちはまずクリアして、TSC のイニ。そうすると、TS コンフィグっていうのができる。で、ここはいらない JS ファイルは消すと。そして、TS コンフィグ。おー、結構ある。これが基本的にできるということね。
Which we don't want yet. So let's have a look at a few settings here, which we'd probably consider as really important settings, which are already commented out. So the first one we want to see is our root dir. We uncomment this, and we can see that the root dir actually specifies the root directory of input files. And it says used to control the output directory structure without dir. So we can go ahead now and set our root dir. The convention is to actually have the root dir as /source. So that would be the source. And then the out dir is actually redirecting the output structure. So this actually controls the file structure and keeps everything organized, the JavaScript folders and the TypeScript folders in different places. So if we have /dist here, then we can see that TypeScript is going to be expecting to find a folder called dist and a folder called /source on the root. So let's go ahead and create those folders. So create a new folder here called dist, and a new folder here called, not inside of dist, so we're actually inside of the root, called source, src. Okay.
そうすると、そうすると、ルートディレクトリ。アウトディレクトリの下に、あった。モジュール。分かれてる。新しくなってるな。ルートディレクター予点/src。hello.js emit でアウトファイル、アウトディレクトリイコール これまで後でいろいろやってみた方が良さそうですね。そこにリストができて、フォルダーとして SRC。SRC には1、2、3移動する。同じようにタイプ TS も移動と。
Now simply, we want to transfer all of our TypeScript files into our source folder. Do it again. So everything's now moved into the /source. So if we cd into there, and we're now inside of here, we see all of our TypeScript files here. If we clear our console here, and now we can go into our console and simply give a command tsc, and TypeScript will go ahead and look inside of the source folder, compile down all of our code, and if we open now our
こうやってから、SRC、つまりタイプスクリプトが入っているファイルで、違う。入ってるところで TSC とやると、リストに JavaScript 4つが出てくるということですね。
This folder, we can see that all of our JavaScript files have actually been created in here for us. And whilst we're still inside of our source folder here, if we just simply go ahead and do tsc-w, what we can do here is create a watch mode for all of our TypeScript files. So if any of these are actually changed in any way, then we can see that it's actually alive. That could be for any file inside of that ./source folder. Finally, if we go back into our tsconfig file here, you may want to have a look at using the no emit true option, which prevents TypeScript from emitting outputs or compiling the code down to JavaScript and emitting an output to JavaScript file if you just wanted to actually see the changes yourself for the sake of type checking your own code. You could do that by setting this option to true without it actually creating these files and compiling down each time. That wraps up pretty much some of the main. Obviously there are a lot more options in here that we can actually do. Feel free to check the documentation. But that wraps up what we needed to cover here for important settings for our projects. And that also completes the course here on TypeScript. Happy to actually have got to the end of this, and I hope you've learned a lot along the way. Thank you for taking the course. If you have enjoyed the course, then please consider leaving us a 5-star review. It does go a long way to helping us to keep making these courses for you. Thank you very much, and I look forward to seeing you on the next course. Goodbye.
Go to project home. OK。これでビデオはおしまいと。で、クイズをやってみる。じゃあ、とりあえず。Which is the typeset of JavaScript. Which is compiled down to JavaScript. 今は通じているのかな。What continues to prepare types file, TSC ファイルね。Which of the following is a valid union type value? これですね。ここはです。Which of the following are valid class member for the in the この3つは使える。Which of the following is valid to tuple? タップルってのは2つか3つの書がこうなる。As interface used to define the shape of an object. The following is a valid tuple is ダメだ。もちろんファルス。How can we create this select function of depth that expresses a number of to be returned? んこれですね。関数式だから。A cross party marked as private is private to use as a class. 当然、ファルス。これで送信と。はい、全部クリア。タイプスクリプト、サクリプト。送信と。これで、やったから、コースサーベイは、まあ、スキップするわけにいかんか、さすがに。FF00。サーベン。環境開き。What was your primary manipulation for this project? これかな。How to say that? いや、アップしよう。Before you took this guide project, how would you discover your confidence in him? ベースのタイトル。Yes. Next. How to use this guide? How would you discover your next? めんどくせえ。ベリーサティスファイドに添えておこう。How does the amount めんどくせえ。完了でいいや。というわけで、 タイプスクリプトは終わったと。じゃあ、いいかな、今日は。そうね。リアクトとかは今度にしましょう。というわけで、ここまで終わったので、今日の勉強はここまでにします。ありがとうございました。
ディスコンネクト。
ライブ終了と。